Thank you for inviting me to join this meeting. I'm happy to be here to discuss the status of embedded Linux. This is the September 2025 edition of this talk. And my name is Tim Bird. I'm a principal software engineer at Sony Electronics. And a lot of you have seen this talk before. You kind of know what it's about. But basically, I just periodically take a look at the status of embedded Linux. Again, this is not comprehensive. This is just a few of the things that we saw, that I saw. There's no way to cover everything, and so I apologize in advance if I missed something. I've divided this into two main parts: the fire hose or the shotgun part, where I just talk about a whole bunch of stuff rapidly, and then I'll slow down a little bit at the end and talk about some of the major themes I think that are interesting. Um, there's one in particular that's pretty interesting. Um, here's the major outline. I'll be covering these kind of main five areas, but let's start with the Linux kernel. Um, and these are the kernels. Nothing really shocking here, except that we had a release on a Monday. That's how exciting it gets for kernel releases. They're always on Sundays, except we had one this year that was on a Monday back in March. And then because of that, we had we had one that came out on Memorial Day weekend that was because the last one, the one before that was on a Monday. This one, it was released actually on a Sunday, but that made it a little bit shorter, 62 days. That's as exciting as it gets in the kernel version scheduling. So we're on 6.17 RC5, release candidate 5 right now. My prediction, and it's not a very risky prediction, that we'll probably have the 6.17 release on September 28th. So the end of this month. It doesn't matter really if it comes a week earlier or a week later. It probably won't come early. I haven't seen any earlier ones, but every once in a while there's one that's like an extra week. But I haven't seen anything major show up, so I think that's probably a pretty good guess for the date. So in terms of looking at, let's see, how come this is not, there we go. Going back and looking at what the features were for some of those releases, I'll just do about the last year's, which is about 5 or so releases. So in November of 2024, we had 6.12. We had a bunch of preempt RT enablement. So the preempt RT patches had been accepted by Linus in September of last year, but there were some additional things that needed improving before they were fully enabled. Also, the security module subsystem can now use static calls. So there was security always has an issue with kind of performance because it's interjecting into some of the normal code paths to do security checks. And so you want it to be as fast as possible. And it was using indirect function calls. And there's an option now to actually use what are known as static calls. So those indirect function calls can get replaced with at runtime with direct calls to functions. So that's kind of self-modifying code, but we do a lot of crazy stuff for performance reasons. The tracing ring buffer can persist across a reboot. That's really nice for debugging problems that maybe you had a trace running, and if you're in particular if you're trying to trace kernel panic, the ability to retrieve that data from the next instance is really nice. They have the integrity policy enforcement security module was added to the kernel. And then also in 6.12, we had the extensible scheduler that was added. And this has been something that's been going on for a long time. It was originally slated to get added in 6.11, but there was a lot of debate. There was a request for a delay, but Linus didn't really want to do that. And so there's a lot of, especially, well, the two areas I've heard that are really using this are gaming machines that are using Linux in gaming machines. That's primarily coming from Valve. They have special schedulers to handle interactive game performance better. And then in high-end workloads, so cloud servers and Linux that's used in data centers have specialized schedulers for their workloads. So this allows you to create a custom scheduler for your workload, and you can read up on how to do that there. There's actually a bunch of sample schedulers already available, and this is being used in production now. So that's pretty interesting. A little bit more news on the 6.12 release. It was selected by the Civil Infrastructure Platform for its next SLTS release. So the CIP project is supporting stuff for 10 years. That's a long time. But 6.12 is now one of those in that category. Let's see. On the 6.13 release, just a couple of things. ARM64 can run Linux and virtual machines. They also got support for shadow stacks, which is a security mechanism, security robustness mechanism. The lazy preemption patches have been merged, and I'll talk about those later. There was a new thermal threshold system that was added so that user space can get notifications when device temperature crosses a threshold. And there was enough Rust support added for VFS data structures and interfaces so that we could add a Rust implementation of Binder. So Binder is an IPC interprocess communication system used on Android, and it was recently rewritten in Rust to be more robust. It's kind of a complex piece of code. It's for Android tasks to communicate with each other, but that binder had originally been written in C. It was a normal C module in the kernel, but now it has been written in Rust. I don't know if they're using the Rust one in production yet, but that was quite a feat, I think. Also in 6.13, we had multi-grain timestamps, and we had a new madvise operation to install guard pages. So more kind of security for handling. So if you access a guard page, you'll get a SIG-SEG-V segmentation fault. So some additional security. RiserFS file system was removed from the kernel. It's a file system that had been inserted, oh man, many years ago, probably over 20 years ago. But the flash-friendly file system, F2FS, now supports device aliasing. So that allows a portion of the blocked device to be used temporarily by another file system. And I can't remember why that was interesting, but I think it was useful for some use case in the embedded world. On 6.14, now we're getting to March of 2025. There was a new flag added to exec VEAT. AT exec VE check. So this allows a program to find out ask the kernel about the executability of a file. So it allows a security system from user space to ask about the security for scripts. So it's always been a problem for programs to trust scripts. And because they're interpreted, a lot of crazy stuff can happen in them. But this allows you to perform the same, from user space, detect the same types of security checks that you would normally do for a regular program, you can now do on scripts as well. So there was also a new DMEM control group controller that can be used to regulate access to device memory. And then the FuSafe file system which is actually used fairly frequently. I think Sony uses this in their TV sets for some of the things. But anyway, it can now use IOU ring. So IOU ring is kind of the new async mechanism for scheduling IO in the kernel. And so you can have a user space file system supporting that. Then in May, we had kernel 6.15, and there was a new kernel command line trace off after boot that automatically disables the tracing once the init process starts. That's really helpful for capturing boot trace data keep it from being overwriting your trace buffers. And then Fuse also supports handling timeouts. This is useful because when you're running a file system in user space, if something goes wrong with user space, you could have the server hang, and that's bad. So this allows you to recover from that. Now, getting into the last couple releases, the last released kernel, 6.16, had a bunch of these features. So it has lazy preemption support for ARM64. That's a real-time feature. I'll talk about that later. Core dumps can now be sent to a Unix socket. IOU ring can be used to create pipes, so they keep adding features to the IOU ring mechanism. There's command line option for enabling or disabling group scheduling of real-time tasks, so some real-time additions. There were big performance improvements on ext4 file systems, having to do with the block layer and how things were scheduled there. And then freezing and unfreezing of file systems and EFI variables on suspend, resume, and hibernate and unhibernate options. So some better suspend resume behaviors. And then let's see. There was a big timer API refactoring. So renaming functions to start with timer underscore, just so they're easier to read in the kernel. And then USB audio devices supported audio offloading. So it's kind of like DMA for audio, but over USB. So USB audio devices, they can keep playing even while the rest of the system can go to sleep. So for certain products, that's very handy to save power. And then the overhead of SE Linux has been reduced with caching and wildcard support. So some of the matching that goes on, there's a lot of matching that happens with security to associate the security properties with the attributes that you're keeping secure. Most of the time, that's file system attributes, but there are other resources. But anyway, so SE Linux has been kind of notorious for having some high overhead. So they added caching and wildcard support to allow that matching to be faster and easier. And then 17, which we have already been through the merge window, obviously. We're at release candidate 5. We expect it in September this month. So a couple of things that are interesting. So we have support for the uniprocessor. So actually, there's no more support for uniprocessor. So the uniprocessor configuration is removed. So you cannot run a single processor kernel. Every kernel that you build now will be an SMP kernel. You can run a single processor machine, right? So you can run, but it's going to have all of the attributes of an SMP kernel, which means all the concurrency and the locking and all that stuff will be inside the kernel, even though you're only running on one processor. So, I mean, the locks obviously you won't have any lock contention between processors, but it simplified the code to not have to deal with those two different cases of a uniprocessor machine. So that actually makes the kernel a little bit bigger, which is a little bit disappointing. But I think uniprocessor machines are getting rarer and rarer these days. There is initial support for proxy execution, and I'll talk about that when I talk about real time. And then USB offload, some more stuff happening there. And let's see, more ext4 file system speedups. BPF programs now have standard out and error streams. And there's a new RTAP monitor for finding real-time app problems, and I'll talk about that as well when I get there. So this is kind of what I took this snapshot back in August, but this is kind of what the Linux kernel looks like. You've got a bunch of stable releases for 6.15 and 6.16, but 6.16 is kind of the top of tree production, but 6.17 will be released shortly. And then you have long-term kernels that are supported all the way back from 5.4. But a bunch of those are going to drop out. The support for those is going to drop pretty soon. Anyway, from 5.4, 5.10, 5.15, 6.1, 6.6, 6.12. And so those are getting back ports of bug fixes. In terms of contributions by embedded Linux companies, this is something I kind of go out and look at. There's specific companies. A lot of these are in Europe, BeLibre and Bootlin and Collabora. All these are companies that do SoC upstreaming work, and they also support specific areas. Linaro is famous for supporting a lot of device tree stuff and Qualcomm things. Lindytronics is famous for doing preempt RT. But you can see the number of commits since August of 2024, so a little over a year. Um, and you can see the top contributor for each of those. That contributor was not responsible for all of the commits for the company. So I think Christoph has like 1,500 commits. He has a ton. Christoph Kozlowski. A lot of because he does a lot of driver fix-ups and refactoring. But this just shows you kind of the work areas. And that's the work area of that top contributor. So this is the number one contributor in each of those companies and what they were working on. So David Lechner was working on the IIO subsystem and ADC drivers, SPI offload, and using some structure things instead of memset for initializing some of the data structures in the kernel. Miguel Reynal was working on MTD, SPI NAND, and SPI memory frequent switch work. Colabora has been working on the MediaTek processor. And then you can see the other things that people were working on. So you see a mixture of device drivers, things having to do with flash memory, IIO system. That's the industrial IO system. And then you also see GPU things and a lot of SoC support. So Toradex is working on Freescale, Linaro is working on Qualcomm, Igalia is working on AMD. So actually, that's really good. I think it's showing a lot of different companies working on a lot of good stuff to improve the kernel. This is the chart for number of commits and number of developers for release. It's pretty stable. There's a little bit of a dip for 6.15 and the number of commits, but nothing too scary. So we're getting about, between 13 and 14,000 commits on each major kernel version. So that's a lot of for v6.16, which is the latest released kernel, we had about 2,000 developers. That's been pretty consistent recently, and about 14,600 commits. That's been pretty. So overall, nothing that exciting. Sorry. But this was exciting. So there was Sasha Levine gave a talk at Open Source Summit North America. This was back in June about use of AI. And so Sasha is using AI for maintainer tasks and for building tools to help him with maintainer tasks. But this was the controversial part. He also submitted a patch that was written by AI. So he submitted AI generated code. That patch is now in the kernel. There are a couple of the reasons that was controversial. Well, one, kernel doesn't have a policy or did not have a policy written down as to whether that's allowed or not. But also the maintainer he submitted that to didn't know about the use of AI. And there's people who still have reservations about the legality of accepting AI generated code and the quality. There's a lot of concern about quality. And I'll talk a lot more. I have several slides here where we're going to talk about some of the AI issues that AI is bringing up. So there are patches that are in the Linux kernel now, besides this one that Sasha submitted. The one that Sasha submitted is still in the kernel. And in fact, I think it's actually been improved upon again by AI. But there's patches now that were either generated by AI or where AI was used as an assistant for the code generation, and unfortunately that no one knows about, right? So there's AI code in the kernel that we don't know about. But that's in addition to the stuff we do know about. So This talk, I highly recommend going back and looking at the talk and reading the article. AI is already showing signs of being really helpful in some areas, like tool development, testing, and code review. That's not so controversial because that is not generating code that you end up shipping and having license obligations for, or potential copyright issues for. Well, you might have copyright issues with tools or even with unit tests or something, but it's not getting shipped out in products in millions of units that you might have to recall if there's an issue. So that's um, so there's a lot of interesting discussion. So this raised a bunch of discussions on the kernel mailing lists. So Sasha also, in addition to submitting some code, he also proposed some patches in July for some rules to establish rules for AI agents. So it turns out that when you're developing, you can set some context for your AI agent or your AI system. And so his rules did things like incorporating the coding style guide for the kernel. And the AI agents read these rules and incorporate them into their operation. So it tells the AI how to format commit tags, how to, abide by the kernel's coding style. It's pretty interesting, actually, what current AI agents can do. They're pretty powerful. Um, but it does raise the issue, well, what is our policy? Do we accept AI generated code? We don't know. That is a topic of discussion. That people are planning on having a big discussion in December at the Kernel Summit, which will be uh, either adjacent to or during Plumbers in at Linux Plumbers Conference this year. The problem is that we expect that AI will probably generate a lot of low quality patches or patches with some subtle bugs, and that will increase the burden on maintainers. That's what's been happening with other projects, and particularly the curl project has seen a lot of problems. And there are also unsettled legal questions about copyrights and licensing. So the Linux Foundation does have an AI Gen guide document, but it leaves policy to individual projects, and the kernel has not selected a policy yet. Implicitly, since we accepted Sasha's patch and it didn't get reverted, I guess we're taking code, but there's been a lot of discussion about that. Um, so yeah, so there's been a ton of discussions on the mailing list, on the kernel summit list. And there are some concrete proposals that if we're going to accept AI, which I think we are going to do that we need to flag it. So there's a new tag that's being considered to flag AI generated or AI assisted commits. That don't quote me on this. This is one proposal. I think it'll shake out probably at the kernel summit what people need to do when they're submitting AI generated code. There's also a proposal to actually create some policy documents, but there's not consensus yet on what the policies should be. Uh, well, unfortunately or fortunately, whatever your opinion, AI is already proving useful for development. Sasha said it's very, very helpful. It has increased his productivity for maintaining the stable kernels to have AI reviewing code and helping him categorize. One of the biggest chores is determining whether a patch needs to be backported, and he has AI assisting with him with that already. Um, so again, it'll be a big discussion at Kernel Summit in December. And then I have some views I'll share at the end after I talk some more about AI later in this talk. So let's go through some technology areas. So a lot of the things that I have in this section are based on talks that I saw. And I'll have references. I'll either have the titles or sometimes the titles and the author or the speaker. But if I refer to something for ELC Europe, you can usually find the slides at this top page, ELC Europe 2025 presentations, and you can get the slides and the video links. And then ELC North America there's a link there. And then I also this year I went to embedded recipes, and so I've got a link there for the slides videos for those. And so you can search those lists by title or presenter name. Maybe you can Google those, but searching on the page is probably faster. So some things. So the bootloader. So U-Boot, there was a really great talk on U-Boot by Simon Glass at ELC North America. Talks about a new organization of the boot process. So U-Boot has gotten kind of complex over the years. It does a lot of the current, well, the legacy system is kind of environment based. You could use U-Boot environment variables to build up commands that then would give you flexibility to set the arguments and decide which method of boot you're using, whether it was an NFS boot or a TFTP boot or booting from Flash or whatever. But he's replacing that whole system with a new system called boot flows. So these are boot flows are a set of commands that are discoverable by U-Boot. So you can actually put a boot flow config into a file on a file system that U-Boot can discover. So like a Raspberry Pi could come with the configuration needed. You don't have to describe it to U-Boot. U-Boot can discover it, and it runs a set of commands that, finds the bootable items like the artifacts, the kernel and the device tree and initramfs and stuff like that. You can modify the parameters and actually perform the boots. So a lot of interesting changes coming in U-Boot. What this allows is that theoretically it allows you to build U-Boot without support for the command line, right? So if you don't have all these environment variables and you don't require interaction with the user, you can actually compile that whole part of U-Boot out. Bootflow makes the command line unnecessary. Well, if you're not allowing interaction, but anyway, in any event, if you do compile that out, you can make a much smaller U-Boot image, and you can. Simon Glass said he could get to the Linux kernel in 100 milliseconds, which is pretty fast, much faster than what's going on now. And then some other things that are coming are a GUI menu and maybe even a text editor. So for modifying config actually in U-Boot itself. So some very interesting stuff going on with bootloader. What I personally have been working on a lot lately is the boot time special interest group. So I've been doing a lot of boot time work. This is a new initiative to coordinate boot time reduction activities. We're planning a new guide, documentation for boot time tools and tricks. If you want to get involved, we have a monthly conference call. The next one is September 23rd. That's 9 a.m. Mountain Time. I'm sorry, I don't know what that comes out to in Japan. It's probably like 2 in the morning or something terrible. I apologize for that. But if you want to get involved, we're doing mailing list for discussions. I have a data repository. There's lots and lots of work to do, and people are doing a lot of work. So TI is working on stuff for their automotive version of Linux, and Red Hat is working on stuff also for their automotive version of Linux. Sony's been working on stuff. By Sony, I mean me. I've been doing some regression testings, deferred init calls, a boot time tuning tool. Qualcomm and Google are also doing things to help with their respective products. So there's a lot of stuff going on, and we're trying to have an organized effort. So at ELC North America, we kind of had a mini boot time track with several different talks I talked about regression testing, but there were people talking about how to do early Ethernet, early boot and late attach. And then at ELC Europe, we also had a whole talk on what is the impact of adding security to the boot path, which I know in automotive, they're very paranoid about the security of not letting the cars have malware and get introduced. But it has have an impact on boot time, and there are some mitigation techniques you can use. And then also TI presented this unified boot time measurement. We're trying to do stuff where we can measure not just the boot time of the kernel, but also integrate that with the boot time of the bootloader and user space and try to come up with a unified process that works over all of those domains, particularly on multi-processor systems. So there's a lot of activity going on with boot time. For Rust, the best talk I've seen on Rust was John Corbett's talk. This was actually last year at Open Source Summit Japan. And so I trust that you can look that up. But basically, things are kind of moving along. The thing that was kind of interesting was that I heard Greg Kroah-Hartman say at the Member Summit last year that Linus says the future of the Linux is Rust. So I think it's gonna. There's some maintainers who are kind of not believing that it's gonna happen, but if Linus is leaning that way, I think it's gonna happen. Not that everything will be written in Rust overnight, but that it will become a first-class citizen. You will actually see drivers written in Rust to handle, and the whole purpose is to make them more secure, more robust, uh, less prone to like memory errors and locking errors and things like that. There was now something that's on its way out. So Rust is on its way in. Something that's on its way out is support for 32-bit processors. So there was a really good presentation by Arne Bergman at ELC Europe in Amsterdam talking about 32-bit Linux support. He had some really good charts talking about all the different platforms. So Arne is the kind of the maintainer over all of ARM in the kernel, but he's been looking at where 32-bit systems are still produced, which are still being even manufactured. A lot are not even being manufactured anymore, the legacy ones. And he's worked out what are the pain points and where might we start getting rid of stuff. And there's actually active work. There was discussions this week on the kernel mailing list about HiMem and whether or not we could get rid of that. That's a system that allows a 32-bit system to do some tricks to get more than 1 gig of memory. Normally, you can only get 1 gig of memory. Anyway, so some of this stuff, HiMem and NoMMU support may be disappearing as early as 2027. That's just 2 years away. So if you so Arne's presentation and the recent kernel emails are a call to see what the impacts might be of removal of this stuff. So bottom line, if you want 32-bit or if you want the kernel to continue to support 32-bit platforms, you may have to step up and maintain it and provide workarounds for some of the issues that are raised by that. In terms of file system and I/O, very interesting that we saw big performance gains in ext4. I think it's like on the order of 10 to 15% for performance gains, which is amazing for a file system. A lot of it had to do with better scalability for block allocation, so I'm not sure how much that's going to help. When we talk about scalability, usually we're talking about bigger systems, right? These enterprise systems that have scalability issues. But it may also be helpful for embedded. Bcachefs is probably on its way out of mainline. So if you're using Bcachefs, and I'm not going to get into the reasons for that, there are some maintainer disagreements. I don't think Linus trusts the maintainer of Bcachefs anymore. Anyways, so just be warned. I would not introduce a dependency on Bcachefs right now in your product. A couple of things on networking. There's actually a couple other ones, Wi-Fi and Bluetooth, that were at ELC Europe. But if you're interested in real-time Ethernet or the thread, there are some good talks on those protocols and some of the issues there at ELC Europe. So things are kind of rolling along with networking. And then in terms of power management, there was at least 4 different talks talking about power management. There was remote core power management and AMP systems. That's asymmetric multiprocessors. So being able to control the power from Linux, controlling the power of other processors in the system. So a lot of these embedded systems have multiple cores that have specialized tasks. the messaging and the APIs for controlling their power management. And then a really good overview of just Linux power management in general. And this was part two. Part one was last year. Um, and then why won't my CPU sleep? Debugging CPU idle mysteries on ARM SoCs. So idle is just one of the issues that you have to deal with, is making sure that you go into the proper sleep level for different idle durations and all the issues around that. And debugging through that can be quite difficult. There's a lot of stuff having to do with device tree and making sure that your governor is correctly coded. And then the last thing kind of having to do with power management was designing fail-safe embedded Linux, designing for power resilience. This talk had to do with notifications, so that making sure that Linux could get notifications when power was removed. So not really power management as much as power robustness, but anyway, all having to do with power. So look those talks up if you're involved with power management. Then real time. Okay, so we all know that preempt RT finally made it in the kernel last year. So what is going on? What's the new thing that are happening? So I think the biggest issue going forward is now that so there are people at Linutronics um, who are maintaining preempt RT, right? There's still additional patches and finding areas where you need to yield the processor and stuff for real-time behavior in the kernel. But the preempt RT is now in the kernel. You can turn it on, but that doesn't mean your app's going to work correctly. Your app still has to be a properly written real-time application. You have to use the scheduler correctly. You have to make sure that you do not do operations that kind of break out of that mode. A classic thing is that you have to lock all your memory down. You have to, if you can, you avoid interrupts, or you put your real-time app on a processor, lock it so it's only gets scheduled on a processor that does not handling other interrupts. So there's a lot more to it than just turning on preempt RT. So what's going on now is there are tools, there are modeling tools, and there are monitoring tools to help you find issues with your application. So one of them is the RTAP monitor. So it's basically a state machine, but so the kernel already has a monitoring system to kind of watch what's going on and send notifications if it sees weird behavior. But the state machine it supported was not sufficient for what they wanted to do with this RTAP module. And RTAP, I think, just stands for real-time app. So they added some support for linear temporal logic. I don't even know what that means, but it was added to the monitoring system. So it's added extra semantics that were required for the RTAP module. And then they added the RTAP module. And so this thing, when you're running it and you have an RT process running, it can detect if you're doing a page fault during a real-time process. That's a big no-no. A page fault is gonna cause all kinds of delays. It can find out if you're doing weird sleeps. For instance, if you're doing sleeping or an interrupt of an RT process when it's not appropriate, you can detect priority inversion, which depending on your app may or may not be allowed. Anyway, there's a whole thread on this. And there's also been a lot more work on priority inversion handling in the kernel. So let's talk about that. Well, actually, the next slide. So this slide, lazy preemption. So it turns out that the way that we're currently doing handling preemption in the kernel could be improved. So there's a set of patches that have been they've been started, and some progress has been made to change the way preemption is done when you're not in a full RT mode. So previously, there were several different modes you could be in in the kernel that had different effects on how the code was compiled and executed. In particular, okay, so you had these preempt none, preempt voluntary, preempt full, and preempt RT modes. And the way the kernel has been supporting real time is by making sure that it never had these super long, these places in the kernel where the kernel was essentially non-preemptible for a really long time. And what originally happened was over the last 20 years, they put in a bunch of these conditional reschedule calls, which is basically a yield operation. But they're sprinkled everywhere and they're hard to maintain and they're also inaccurate. Other non-real-time developers are not skilled enough to kind of maintain these, and so there's a lot of work being done by Linutronics and a few other people to maintain all this. Well, they figured out that they could actually remove those if they kind of made it a lazy reschedule. And so uh, this indicates that a preempt is desired, but is not needed right away. So it's not appropriate for the preempt RT mode, but it will replace preempt none and preempt voluntary. And Thomas Leixner estimated that about 95% of the conditional reschedule calls could be removed, which would be a big maintenance improvement. So it has to do with real time and improving real time performance and limiting the length of non-preemptible sections of the kernel. But when you're in hard RT mode, this is not you don't use lazy preemption. Um, but you might use proxy execution. So this is also a new thing. So the kernel has mechanisms in it already to handle priority inversion. And so the current way that works is you have priority inheritance locks. So that means that when you get a lock, when you need a lock, even if you're a high priority task and a low priority task has a lock on a resource that you need, the scheduler can detect that and schedule in, even if it's a low priority task, it can kind of give that task enough resources, enough CPU to get through and get that lock unlocked or free that resource up. But it's right now that only works between processes that are in the RT or deadline scheduling class, um, or actually only for the RT scheduling class. It doesn't work with other processes. So you might have a process that where a situation where you have a process that's not even a real-time process, but it's holding a resource and it's kind of blocking you. Um, and so this is a system to deal with that case. Um, and with the current priority inheritance mechanisms, a task gets the priority of the blocked task, but it might not be scheduled immediately. With proxy execution, what happens is instead of just saying, well, schedule this other guy as soon as possible, it will actually run the other lower priority task uh, immediately in the context of the lock requester. So the accounting for this is quite tricky, and the feature is not all the way supported yet. Current work is is in the kernel for the groundwork for this. So building up some of the infrastructure needed for this went in 6.17. So it actually hasn't even been released yet, right? Um, but there's a couple of other things like donor migration, where the lock holding task is migrated to the block task CPU. There's a bunch of complexity here. It's a more complex system, but it should actually result in even better real-time performance across a wider range of scheduling classes. So this is something to watch in the future. Um, Security, what can I say? It's a very hot topic. There were 9 talks at ELC Europe on all kinds of different aspects of security, looking at security related to boot time, about OPT, boot stuff in the bootloader, thinking at it from from uh, uh, from the consideration of, how are humans acting. So all of these are kind of interesting if you're interested in security. I didn't have time to go into them, and it would have been too long to detail all these different talks. But a lot of this is being driven by the CRA. So the Cyber Resiliency Act was published and entered into force on 10th of December. Right. So its main requirements. So this is an act in the European Union that actually has some pretty stiff penalties uh, if you don't keep the security on your product up. There's a special carve out for open source maintainers and contributors, and for a special category called open source stewards, which is good because you don't want to make some poor volunteer responsible for the security for, like, all of Samsung's TV sets. That's crazy. That would really kill the open source movement if suddenly all of the contributors became responsible for product liability. But we are going to start seeing some stuff. So as of today, no, then not a year from today, 11th of September, 2026, we're going to see reporting requirements where companies will have to report how well they're doing with vulnerabilities, and they're going to have to be able to report what their supply chain looked like, their produce SBOMs. And then the main requirements will start applying on in December of 2027. So there's still some time, but there's a lot of standards work in progress right now on this. So actually, the LF has a good training course on this. I think this particular course is free. I'm not positive, but there's classes you can, if you need to understand this and learn about it. The LF has resources for that. And then if you are a maintainer or an open source contributor, there's some resources here on what you need to do as a project. And there are some specific files you need to have in your repository to indicate that you are aware of the CRA and are assert that you're doing the reporting you need to. Like, one of the things you have to do is provide a security contact. So usually the top maintainer of the project. Okay, so now testing. So Linux testing project had a release, lots of new tests and fixes. There's been LTP can now be included in Valgrind, and they're working on a new reproducible test output format that can easily be diffed. So that's just LTP. Also, very interesting, the Automated Testing Summit. This is a summit that we had a couple of years ago that got revived, and there was actually one in Denver in June. It was co-located with Open Source Summit North America. So we're starting to see a conference built back up. So Automated Testing Summit only happened 2 years. It was before COVID. COVID kind of killed it, but now there's enough companies interested in kind of collaborating to get that going again. And here's some of the talks that were at it. There were talks at ELC 2025, um, and also talks at Automated Testing Summit. So Shua was there talking about the K-test, K-self-test, and Chuck Walber gave a great talk on code coverage and how to use LLVM to do that. And then finally, there was even more testing talks at Embedded Linux Conference Europe. So graphic testing without hardware, kernel CI, and using LabGrid for the Yocto-based products. So check all that out. And finally, just this morning, we had the first work group call for a new work group, the kernel CI lab work group. I was supposed to fix this with a reference, but I couldn't find one. I will try to, if anyone is interested in joining this particular work group, I don't know where they're publishing like their meeting minutes and like how you get on the call. I couldn't find it in time to inject it in this, although I was on the call this morning. But anyway, if you are interested, if you're running your own lab and want to integrate it with kernel CI, then let me know and I will get you hooked up to the people who are doing this. I think I know they send some notifications to the automated testing mailing list. Anyway, tracing, the new thing here is Perfetto. A lot of Android has this really nice tool that allows you to view Linux, uh, trace Linux and user space processes. The kind of unique thing about it is it allows you to do SQL queries of the trace data, and it's actually already available as a layer in the Octo project. So I'm going to go quickly through some of these. I don't know how long I'm supposed to go, but I'm probably going over time. Let's see. Build tools and distros. We've got the Octo project. Walnut Scar was released in May. There's the Scarth Gap migration guide. Oh, the next LTS will contain RISC-V support. So Yocto project is going to start supporting RISC-V. There are one of the things that's come up is that Yocto project is kind of a beast to configure. And so there's multiple projects that are trying to solve that problem. There's one that's kind of the official blessed one, and there's one that's already working, but it's a third party. So BitBake Setup is a tool or a command that's being created as part of Yocto project itself by Alexander Canavan. And this allows you to select, so with a single config file and a single command, it will download all of the meta layers you need, configure stuff up, select your boards, and go off and build an image. So it's supposed to be, as it says, a single command, and you can produce a complete Linux system. This one is in progress. The other, so it's not finished yet. The one that is finished uh, and is actually being used in some places is called CAS. I don't know what CAS stands for, but there was a good talk about another system called ISAR and CAS at Embedded Linux Conference Europe. So Siemens has been using this quite a bit. This is based on Yocto, but with binary Debian packages, and it also uses CAS. And this presentation that I quote here shows how to very easily, it says very easily create your own Raspberry Pi image and go customize it as well. And so if you're interested in that, there's a lot of reasons why you might want to base your system on Debian. This is kind of a weird cross between Debian and Yocto, but anyway. Buildroot also had some stable releases, and they've got some new configs and some package updates, kind of normal stuff. Okay, so some industry news. I have not a ton of stuff here, but I'll talk a little bit about trade associations and then some miscellaneous stuff. So the Linux Foundation has a bunch of different projects that are related to either specific verticals like drone code and automotive grade Linux, or in general security, or kernel CI for testing, or Yocto project for build system. So a couple of these. So automated grade Linux, Terrific Trout, which is the 20.0 release for automotive grade Linux, was released in July. And I think I'm not sure what year we're on, but the 20th release is pretty impressive. I think these are half yearly, so this is 10 years worth of releases. So it's got Scarth Gap support for Yocto project. It's got an update to Flutter and to Qt. It's got some pre-configured images. So you can find out about the status of this by looking at some of the notes on their wiki, but there was a talk at ELC Europe by Walt Miner talking about the lessons they learned. So this talk was not so much about the status of of the project, but more about if you're going to do a project like this, here's some lessons. So it was really interesting. And I know the space grade Linux people were very interested to see what lessons they had. Um, let's see. And then drone code, decade. Oh, so the drone people were there at ELC Europe this time. And so this was a really good overview of drone related projects and repositories. The drone code project is now 10 years old, and I can remember when we launched it. We launched it, I think, at ELC in was it 2014 or 2015? Anyway, this is used extensively both in research and in production applications. I think this is I mean, there are drones with proprietary stacks like, military or other companies, but this is used in a lot of production things. And they have the project includes software not just for flight automation, but also for ground control, command and communications. And they're working on integration with ROS2, which is robot operating system. So uh, this talk was really good if you kind of want to understand what's going on with Linux in drones. And then another area is space. And this is one is near and dear to my heart. So Ramon is also involved with space grade Linux. They've created a meta SGL repository to create a Yocto distribution for space missions. The group is working on a white paper, CI system, and space related test cases. So the interesting thing here is Linux is already in space. So it's already in space in a big way with thousands and thousands of nodes of like Starlink satellites are running Linux. But there's no there there's no kind of cross coordination or effort between any of the companies. So all the companies that are doing satellites are using their own version of Linux. They're doing their own fault tolerance mitigation techniques. And and nobody's getting their stuff certified. Uh, so uh, so we thought it would be good if, as an industry, we got together and started working on something together. So this is how it started. We got a bunch of people together at NASA last year, and these are representatives from NASA and Boeing and ESA. We'd love to get some JAXA people involved with this. Um, and I will give you an example. This is nothing to do with space grade Linux, but this is a selfie sat. Uh, this is a picture of me and my wife and my grandkids out hiking. And the picture is being displayed on a phone running Linux. And there's a camera on this that's taking a picture of that phone, and it's taking it over approximately the area where the original picture was taken. So actually, that's Utah in the background there. I know you probably can't tell, but and I happen to know when they'd sent me a notification when this was going over my house. So I actually went outside and was waving at it. So you can't see me, but I'm also in this picture. I'm in this picture twice, once in the picture and once on the earth behind. But this is a good example of the type of thing. This thing is called SatGus for weird reasons, but this has an ARM flight computer running Linux, and it has a Raspberry Pi CM4, and I believe they have two of those running. And those are running a Raspberry Pi OS, which is a variant of Debian Linux. And then they also have Google Pixel smartphones running Android, which are also running Linux. And then in terms of connections, they have to have the S-band radio between ground and flight computer. And then they're using Ethernet to talk from the flight computer to the compute module 4s. And then they're using USB between the compute module 4s and the Pixels. So there's actually a bunch of Linux, a bunch of interesting interactions going on here. And this is the type of thing, this is all custom, right? So this is an example of a system that's in orbit now. It's not using space grade Linux. And so a lot of the stuff that they learned, we're not able to share between companies. But we'd like to. We'd like to do more. Okay, so let's last thing, let's cover some miscellaneous stuff. AI scraping, the AI scraping scourge, and Ubuntu and core utilities. So AI scraping is causing a lot of problems. AI systems are getting trained on publicly accessible data, which means it's scrubbing OSS projects and public sites. So email lists are getting scraped, and obviously Reddit and Stack Overflow are getting scraped. But also GitHub and private Git repositories. It's all being scraped for training data, and the scrapers are not well behaved. They change their IP address, they lie about what agent they are, they don't observe do not access standards, and they're scraping very, very often, every few days, even when the content hasn't changed. And they're scraping using web interfaces instead of like the Git protocol. They're using HTTP. It's very, very slow, and it's causing a lot of problems. And so you're now seeing actually the rise of uh, defenses against AI scrapers. So elinux.org now has a defense in place to keep it from getting scraped constantly. Curl had to do this. Lore, which is the kernel mailing list system, had to do this. For They estimated that 75% of the traffic to readthedocs.io was scrapers, even though read the docs is updated not very frequently. I mean, in places it is, but you don't need to scrape the whole thing every couple of days. And this extra traffic is costing real money. So like $1,500 a month to read the docs. And these are sites that are free for open source projects, and they just can't afford to do it. So this whole thing amounts to a big denial of service attack, a distributed denial of service attack. Some sites have had to resort to blocking entire countries. I think the curl project had to block the entire country of Brazil. Um, and so that's not good. Um, I'm not sure what the solution to this is, but AI is causing a big problem with all the scraping that it's doing for training data. So, and I already went over this. LWN.net was affected, and there's a good article about kind of all the things that there are things you can do to gatekeep, like add JavaScript or challenges, but people don't want to do that. It makes it less good for the humans. So lore.kernel.org has a new human detector. But also fake content, AI generated content is a problem. So curl has a flood of AI generated bug reports that are all bogus. I don't know why people are doing this, but they run AI on curl, and the AI says, "Oh yeah, this is a bug," and then they submit the issue, and then a human has to go waste their time looking at it and saying, "Oh no, that's not really an issue." And Stack Overflow also has issues with incorrectly AI generated content. So AI is causing a lot of what we call AI slop to be generated. And if we're not careful, it's gonna overload the maintainers and burn out people and cost a lot of extra money. Um, I'll talk more about that later. Finally, Ubuntu had a change in its core utilities. Ubuntu is allowing users to experiment with testing Rust core command line utilities. So there's a new tool called Oxidizer that lets you test Rust-based utilities. So core utilities, the actual core, there's a package called core utilities, which has the basic things like ls and ps and stuff like that, or maybe that's proc utilities. Anyway, they've been around for 20 years, but people would like to see them be more robust, and so they have rewritten them in Rust. The interesting thing is that this has also licensing ramifications. The Rust utilities are MIT, while core utils, find utils, and diff utils are GPL. So a lot of people don't want to change the license of their code. They see that as a downgrade. Others don't care. But anyway, that raised a big issue. Okay, so in terms of community, the really thing I only want to talk about is conferences. So in the last year, we've had the following. We've had Open Source Summit Japan, we've had FOSDEM, Linaro Connect, Embedded Recipes, ELC North America, ELC Europe. We just had that. And I'll talk a little bit about that. You've seen a lot of talks that I've referred to already. There's too many sessions to list them all. This was just a couple of weeks ago. But we had some great topics. We had a bunch on security. We had kernel drivers and hardware support. We had networking. We had testing. A lot of talks on testings, build systems, flashing tools, SBOM generation, And then specifically about some verticals. So we had automotive, robotics, drones, space, mobile Android, was all there. So in the slides and videos page, the wiki page was just made available this week. So the videos came out, I think on Saturday, and they've already been linked and all the presentations. There's only one set of slides that I haven't gotten. I have to track the speaker down and get those from him. But 99% of the slides and 100% of the videos are all available, and it's all free. It's awesome. So go check that out. Here's some pictures from the conference. This is me talking with Marta. I gave my status talk with Marta Rybczynska. And then, of course, for the closing game, I always dress up as something goofy. This time I was an Imperial officer in charge of the Death Star. So we have a lot of fun at it as well. Um, I did make an announcement there that I am stepping down as the chair of the ELC program committee, and Walt Miner will be taking my place as the chair. So I actually plan to continue on the program committee for some amount of next year, but I'm phasing out. I'm stepping down. So it's been a lot of fun, and I'll, like I said, I'll still be involved a little bit next year. But anyway, that's happening. So some of the conferences that are coming up, so that was the conferences in the past. Conferences coming up, we've got Open Source Summit Japan and Linux Plumbers Conference, both in December, actually the same week, same location in Toronto Hills, same venue as last year. And so that'll be exciting. I'll be there, so hopefully see some of you in person. And then in 2026, we've got ELC North America. These dates are pretty close. I'm not sure the exact dates. I know it's the week of the 18th in Minneapolis. I'm not, it might like be a different set of days that week. And then ELC Europe is going to be October in Prague. And this is something new. We are talking about the possibility of doing an ELC Asia. And that would be in December in Tokyo, most likely. But we haven't decided to do that yet. So what we're trying to do is we're trying to determine the interest level. You know, would we get enough sponsors? Would we get enough speakers? Would we get enough attendees interested in coming? And so some of the people that are in the room or that are using Zoom to call into this meeting might be interested in like a full in-person conference. So let us know what you think about that. Finally, some conclusions. So some themes, where we came from. So just some overviews. We've got use of tools, compiler features, automation to address robustness and security. So we're seeing a lot more compiler features. FDO stands for feedback directed optimization. Got thread on annotations, automated testing, got the rise of Rust. So we're using compiler features and language features to help improve things. We've got a new tool though, and that's AI. I'll talk about that on the next page. But I think the community is more mature and professional and friendly than it's ever been. We have an active code of conduct committee. Linux Foundation acts as Linux's legal, HR, marketing, intellectual property, payroll, accounting departments. And so we actually have very, very good support for the Linux as a project. So AI is upon us. I am both worried and excited. So AI generated code has subtle bugs that will tax already overworked maintainers. So if we're not careful, we're gonna, if we let a bunch of AI slop get into the kernel procedures, that's not going to be good. Maintainers are already overburdened. But so AI is faster, and it may make less mistakes than humans, especially as models improve. Right now, it's making more mistakes than humans would. But if it gets to the point where it's making less mistakes than humans, then that will reduce the burden on maintainers. You can assign AI to do your code reviews. But in the short term, I think it's making more mistakes. You know, it's hallucinating, it's making up function calls that don't exist, and stuff that doesn't even compile. So it's got a little ways to go. And so we're in a really transitional phase here. There's also still some legal issues to be resolved. There's quite a bit of debate about whether it's appropriate for someone to sign off on a patch that was generated by AI. Anyway, I think my personal opinion, we should be conservative with accepting AI code into the kernel, but find ways for AI assistants to help develop and maintain code. And then Marta gave this talk with me, and she kind of has the same opinion. LLM hallucinations are causing real problems, and open source maintainers often don't have the time to investigate how to use the tool, but attackers are using them now. So that's interesting. She has a security view. Um, so where did we come from? Well, I started working on Linux in 1993, 32 years ago. I was involved in the Consumer Electronics Linux Forum, the Embedded Linux Consortium, the Core Embedded Linux Project, all involved in different aspects of promoting or advancing Linux. So what was it like 30 years ago? Well, absolutely no one believed in Linux. Not on desktops, not in servers, and especially not in embedded. So we always, my company Lineo, we were always just trying to get our foot in the door to tell people that Linux could do what they needed. There was no Git. We didn't even have BitKeeper. Linux was using patches and tarballs and email. We didn't have lore. We didn't even have lkml.org. We just had a single mailing list. We didn't even have Google, right? So maybe there was Alta Vista. I don't know. But to find information or to look at archives of the mailing list was not even possible. We had no methodical release process. It was all ad hoc releases. We didn't have code of conducts. We had no trademark, no legal protection. We only had one tool chain, a limited number of platforms. It was terrible. You compare it. What's I don't know how to say it. I don't know if it works in Japanese, but it's like kids these days. They don't realize how good they have it. Um, so uh, we have come such a long ways from where we were. All of this stuff is kind of solved problems now. So, but I still worry about stuff. So what do I worry about? AI, is it going to help or hinder? It's putting stress on open source ecosystems. The one thing I thought was really interesting, just as a thought, is AI doesn't have to be perfect. A lot of people are waiting they're expecting like automated cars to, full self-driving cars to be perfect. Well, they don't have to be perfect. They just have to be better than humans. And then it becomes a productivity enhancer. Um, the problem, though, is if you replace the junior developers with AI generated code, who then in 10 or 20 years is going to become the senior developers? That's a real problem. So maintainers, will we have enough maintainers? I can tell you right now that some of us are getting older. Recently, I've seen some new young maintainers. That's great. Recently, Linus and Greg committed to some more years. In the case of Linus, he committed to 10 more years, which he's already kind of up in, I don't know how old he is exactly, but at 10 years, he's going to be over the U.S. retirement age. I know for sure. So he's going to hold on at least that much longer, but then what's going to happen? So there's this transition period we're going to enter into here. Um, and then universities rarely teach computer architecture outside of electronic engineering programs. So for kernel developers, it's tough to find kernel developers. And then I worry about tools breaking network effects, and they're going to improve test coverage, but the kernel that Android is using is going to be different from the kernel that other the TVs you're using or that's being used in enterprise systems. This might break network effects. Overall, we're doing great. So I want to end on a high note. Embedded Linux is widely deployed and functional in literally billions of devices. Core kernel systems are in place, and they're all over. I think we have world domination. I think there's probably more embedded Linux in the world than any other embedded operating system. But there's always new hardware, and we still have some areas like in outer space where there are barriers to Linux adoption. I can't believe I've been doing this for 30 years. We're not done yet. So what's left to do? Can we get companies to stop making hardware? That would allow us to catch up in the software and just optimize. So, but I don't. That's not going to happen, right? Well, companies are going to continue making hardware. Here's some of the resources I use for this talk, and I did that way too fast, but I'll send the PDF so you can look at these. And then LWN.net is probably the biggest resource I use for this talk. They have a great kernel index that has, if seriously, if there's a subsystem of the kernel you want to learn about, you can go back and find the articles for when it was first introduced, what the rationale was. And they could use some funding. They had an article recently about they, they well, they could use some funding. So please pay for a subscription. I have been a subscriber to LWN.net, a professional subscriber to LWN.net for 22 years now. So I'm doing my part to help them out. And so it's worth it to get a subscription to make sure we continue to have this good resource. With that, I will say thanks and see if there are any questions. And I gotta change my. I don't know where the window got to, where my Teams window is. There it is. Okay. So are there any questions?
じゃあ、皆さん拍手をお願いします。Thank you, Dean.
Oh, thank you.
はいで、質問、コメントある人はいますか？手を挙げてください。マイクを持ってきますので。はい、じゃ
あ。カメラ映ってないです。
じゃ
あ、sorry, just a moment.
Okay.
Sorry, I'm good at speaking English, so I'll use the cheat sheet.
Okay.
Hello, I'm Takahashi. It was nice meeting you at OSSEU 2025. Thank you very much for your time the other day. When I listened to your session at the venue, I was surprised because it was very popular. I think Japanese members should be more thankful that they can listen to the full version of your session. I have a question about the CRA. I understand that the manufacturer will have an obligation to report vulnerabilities starting from September 11th, 2026. However, I couldn't find any sessions that focused on vulnerability reporting in OSS EU 2025. As for the current situation, have many companies already prepared for it, or have most people still not caught up with the requirements? If you know the situation in the EU, could you please tell me about it?
So I actually, well, there's a lot of attention being paid to it. There was a Linux Foundation research paper done. So Linux Foundation does these surveys, and unfortunately, I don't know when the CRA survey was done, but there was a survey recently done on CRA. I'll see if I can find a reference to it. But a lot of companies are not aware of what they need to do. So the ones I'm familiar with, so like Sony is aware of the CRA, and we're actively working. That's why we've got a lot of stuff going on with like OpenChain and SBOMs, uh, and vulnerability analysis. So I think the bigger companies are aware it's coming. The penalties are very big. They're very substantial penalties if you do not meet the terms. Now, the penalties don't kick in until 2027, so that gives people a long time to prepare. But the penalties are so big, that companies have to pay attention to it. They really can't just wait until the last minute to try and fix their stuff. So I have kind of a mixed feeling. I feel like companies have to be paying attention, or but the LF research was that a lot of companies are not doing it yet. So I don't know if that's a good answer.
Thank you.
Yeah.
はい、他誰かいますか？ELC Asia is very hot topic.
Yeah.
はい、じゃあ大丈夫ですかね。Okay, that's all. Thank you, team. もう一度じゃあ拍手
Okay.
を。
Yeah. Thank you very much.
はい、じゃあ